And we are back, hello again, for the second part of this, for the second video. In this one we will be covering the scene manager, the scene, the updatable and drawable, and the alarmable. Let's get started then. Scene manager is a singleton. It's deleted just like everything else. That deletion occurs in the engine when the end of the game occurs, when the game is closing out. It contains an unordered map of strings, which hasn't fully been utilized. I haven't made a big old list of scenes yet and swapped between them. But that is beside the point. So the primary purpose of this is to keep track of the current scene and to execute a swap if need be. Swap primarily happens via a broker that the scene manager holds onto. This is a command pattern, so you issue the broker a command to swap the scenes, and it will perform that. Here you can see this is where it does it. That's really about it. It holds the current scene and it swaps scenes. That's kind of all it does. It's deleted when it needs to be. Onto scene. Scene, here's the full header. Scenes are not actually singletons like the scene manager is. They are individual things. So, first thing to note is the initialize and end scene. So these are used by the user when they make their own scenes. They need to fill out the initialize and end scene, and when the scene is being kicked off, it will boot up both of those. It'll boot up initialize, and then when it's swapped out or at the end of the game, it will run end scene for proper scene cleanup. So if you need stuff in your scene, that's where you put it. Or, well, that's where you tell it to start. But that is not all the scene does. The most important thing that the scene does, aside from those, is its update and draw up. Didn't mean to do that. Actually, this is a good time to just show off that, yes, indeed, you can destroy the other ships. Sorry, I forgot to show that off last time. Anyways, right, back to update and draw. Update and draw, the two big ones. Update has a lot in it, and I will be showing that off right now. So, update. This one runs the broker. So the scene contains a lot of managers. I forgot to mention that. You can see them up here. These managers manage all of the objects in the world, in the game, in the scene. When you create a new object, you register it, which I'll be going over in the other parts, or when I reach the other sections. So the order of operations for the update is broker first, collidable, inputable, updatable, and alarmable. And then draw is just draw. Now I know what you're thinking. There are the 2D and 3D draws, right? Well, that is actually done in the drawable manager. So you can have both, and I will be showing that off with my game with my sprites that you saw in the demo. Right, so these are just registers, the registers and deregister calls. These are for the sake of the broker. So when you need something added to the scene or removed from the scene, you call the broker and tell it to add or remove it from its relevant manager. If it's not in the manager, it won't have its processes done. All right. Yes, and the destructor, so at the end of the scene, when it is destroyed, it calls upon its end scene, which is something that you set. And so, well, its destructor also deletes all the pointers that it has to the managers, but that's, yeah. Didn't mean to bend that. Alright. On to the next scene, or on to the next bit, which will be updatable and drawable. So the updatables and drawables both have a manager. Neither of these managers are singletons. Here's the drawable manager header file, and here's the updatable header file. So these things' main processes is the register, deregister, and process elements. So what they do, and this is a good time to demo the broker itself, is, so here's the broker. So what happens with this game is a updatable, updatables are added to this using the register function, which is called by the command broker. Owned and only the command broker. Only the command broker calls the register and deregister. Instead, what the updatable object has access to is the issuing of the commands. In my case, named quite literally, issue register and issue deregister commands. So those get sent to the broker, and then when it's the broker's time to shine, it will run execute commands and run all of the things to, and run all commands that it has been given of every type. And it can be given any type because it accepts a generic. Now then, it is those commands that will call the register. Then, after they have been added to the list, which in this case is a literal STL list, it runs process elements. Process elements is very similar to the command broker's execute commands. It loops through all of the updatables and runs their update function, which the update function is an overloaded, or not overloaded, it is a virtual function that needs to be replaced. Same for drawable. Actually, drawable has the same register, deregister, and process elements. So you add it, and it will run. In this case, it runs draw and draw 2D. So you have two commands with this one. Draw 2D will be left blank if you don't have any two-dimensional objects to draw. Anyways, let's take a look inside of the actual game objects for drawable and updatable. So here is the updatables header file, and here is the drawables header file. So they have a reference to themselves. Every updatable, or every drawable and updatable has a reference to itself, a registration state, and then a registration and deregistration command. These are its internals. It has scene registration and scene deregistration, which is what's called in the register function and the deregister function when you activate that is what calls the register. Here, I'll just show you. So here's the issue commands, and all they do is they submit a command, which was shown earlier in the scene. Same for updatable. Here are the issue commands, and it sends its command to the broker of the current scene. Then, when it hits scene registration or scene deregistration, it talks to its it calls the register and deregister of the scene. And that scene register or deregister then automatically swaps the or talks to the correct manager and has that run its register and deregister, which we saw earlier. And all that leads to the scene looping through every frame and performing the update and draw of the scene, of the current scene, of every object on the current scene that has been registered. Blah. Alarmables are next. So an alarmable is a little bit different. These ones contain an array of the registration data from before. The reason for this is that they have multiple alarms, and each of those alarms need to be set a little differently. So, as you can see, its register and deregister comes with an alarm ID and a timer, and a float that is labeled as timer. You give it a time that is representative of the actual time, of how long after the timer has been set do you want it to go off. Also, I should mention something. The local references, I didn't show those off before, but what they are used for is instant access to the object. So if you store the reference as its iterator form, what you can do with that is you can instantly get access to the correct location that houses the correct object that you are looking for, and then either do something with it or delete it. And that is relevant in the case of the the updatables and drawables, in that you can easily delete it. It doesn't matter finding it when you're when you're doing the draw or update, because you have to run through all of them always. The alarmable, on the other hand, simply needs to find the first one, because it's stored, because it is ordered in the updatable manager and the drawable manager. They were unordered. This one is very specifically a multi-map, which is ordered. What that means is that it will always put the smallest float first, and that is a good thing, because it means that you will never be checking superfluous things. You won't need to check all of the list if the float that is in front is already too big for the alarm to trigger. Anyways, so much like it, here's the private storage lists, here's the public stuff, here's more private and more public stuff. I forgot I did that. I had to, though. These certain things needed to be placed above other things so that I could reference them down here. Anyways, down here, so this one has a unique register to the other brokers, in that this will call the time manager to get the current time, and then add the timer to that for a max time equivalent to, real time plus however long in the future your timer is set for. And then you store that and return its reference. Erasing is as simple as reusing the reference again. And erasing is also only needed if the alarm hasn't gone off yet, because that's another trick of this. The alarms are not set to repeat themselves. They will delete themselves from their own list as soon as they are done. No other manager does that. That is a unique oddity of the alarm manager. Alright, so I believe I have meandered enough for right now. I will be back with the final video